So welcome to this demonstration of the H&E stain. So the first step is after taking those slides down to water, we then shake off the water and then place each of the slides into the Copland jar containing, in this case, Ehrlich's hematoxylin. Now that's a regressive formulation of hematoxylin, which means that we will be initially overstaining those slides, and then through a differentiation step we'll then be able to bring the level of staining back to the desired level. Now we leave it in there for about 10 minutes, and a good way to keep track of time, as you can see here, is to put some masking tape out on the bench and write down the time when that's due to come off. So after 10 minutes we then rinse those slides. Now you can put the slides directly into the smaller water bath, which quickly makes that water bath fairly dirty. So it's actually easier, less work if you rinse off the excess initially just with the hose there in the largest sink, and then just transfer the slides over once they're essentially clean. If we come around to the side here, you'll get a better look of what's going on. When the tap water hits that reddish mixture of hematoxylin, you might be able to see a slight colour change down in the sink there, and that's because when the hematoxylin hits alkaline conditions, it's converted more to that blue colour, which is the right final colour that we want in order to distinguish it from the eosin. Now we could leave those slides in the tap water for a few minutes or so and they would begin to ripen, but in fact they're actually overstained intentionally. So in order to really bring out the right balance of hematoxylin, we will have to engage in a differentiation step. So you can see, or might be able to just make out if I hold that over a bit of filter paper there, there's a little bit of background staining there on even the glass itself. That just shows you how much hematoxylin is there. So we use acid alcohol. That's the differentiation step. Just very dilute acid in there. Make sure the slide is wet to begin. Give it a bit of a shake. And then my preferred method, because it's manageable and short, is 1, 2, 3. Back in the water bath promptly to rinse off the acid alcohol. So that's a very manageable step, and I find actually for most slides that's about all that is needed using that recipe. Then rather than using the tap water, which takes a bit of time, just apply some dilute ammonia to blue the slide. You might be able to see now it's a nice blue section, and we have actually removed some of that excess stain from the slide. Then for the next two, again, same process. You can see that there's probably a little bit of blue on that slide already. 1, 2, 3 dips in the acid alcohol, back promptly into the water bath to stop the differentiation process. And then final one, we'll do this one before the ammonia. So you see again there's quite a bit of blue background on that slide. 1, 2, 3, back in the water bath. And then just make sure that it's blued. So that's really important, bluing, because you really have to bring out that nice blue-purple colour to contrast with the eosin. Okay, so I've given that 3 dips, and I know from experience with that formulation that that's approximately the required level of differentiation. Rinse off the ammonia. Now, to be honest, if I was doing a whole batch of 12 slides on a tissue that I've worked with previously and I'm familiar with the various parameters, so the choice of fixative and everything else, I'd probably just move on from there in the interest of time. But the correct way when you're trying to optimize staining is to use microscope control, and that's what we'll demonstrate here now. So wipe the back of the slide, mount it onto the microscope, and you don't want it to dry out too much on top, but it's best to wipe the back so there's no water. So this slide looks pretty good. You can see the smooth muscle there essentially has no colour, and the collagen fibres equally have little colour, whereas the nuclei stand out quite well. So that's actually turned out pretty good, and I'm happy with that. So you can put that in the water bath. That can sit there for as long as you like. There's no changes that'll take place there. Now the next slide, again, we'll just wipe the back of the slide just to get off the excess water. We don't want that getting down onto the condenser. Now this one's, it's a bit different. So we can see this is some colon. There's quite a bit of heavy hematoxylin still in the goblet cells. The collagen is quite blue, and the smooth muscle also has a kind of bluish colour to it as well. So that's a good sign of requiring further differentiation. So you don't always have mucin, obviously, and perhaps not always smooth muscle, but with the collagen you can tell that's generally in most tissue. So we just repeat that differentiation. I've given that a couple of dips again, rinsing it promptly in the water bath, and then just putting on the ammonia again to bring back the colour. So that's quite important. Every time the hematoxylin goes into acid or acidic conditions, it will go back to that red burgundy colour, and then we need to bring it back. Okay, so that's had a bit further differentiation, and hopefully that will be getting us a little bit closer to where we need to be. So remember, it's the connective tissue that's the really good test. All right, so that looks nice now. We can see some fibroblasts within that collagen connective tissue there, but the collagen itself is pretty pale, and the mucin likewise is now quite pale. So that's good. I'm very happy with that. And so we'll just skip that third slide for now and move on. So once we've actually got the level of differentiation correct, there's no rush to go to the eosin, so if you're staining some other slides, you can leave it there. But the eosin is made up in 90% alcohol. So in preparation, we simply dip the slide a few times in the 90% alcohol Copland jar. And then the technique that we use here in this laboratory is simply to lay the slide on the staining rack. I'll just remove some of that stain from a previous slide that was being stained with something else, and just simply dispense enough eosin to coat the entire slide. And it's good to be fairly liberal with the amount that you're putting on, because it is made up in alcohol and it will evaporate slightly over the 2 minutes of application. So best not to have a thin film, have a nice meniscus on top, so it's really covering it quite well. And just debating whether I should move some slides there, get the excess stain off my hands, and I think I'll do the third one up top. So as you can see, you can do multiple stains at the one time, but you do have to be careful. So I probably should have moved those other two slides down a little bit, but as long as you're careful and you're not contaminating your slides, everything should be okay. And then finally, just applying the eosin to the last slide there. So 2 minutes is usually pretty good. After 2 minutes, we simply tip off the excess eosin, and we don't rinse in the water bath. We go straight to 90 because that's what the eosin's already in. And notice the technique here that was demonstrated in an earlier video. Placing the slide at an angle rather than going down into the slots there. Rinse the slide and rinse the forceps within each Copland. Give it a bit of a tap as we're transferring to drain off the excess fluid. Again, sideways in, and that's the higher level of alcohol, as you can see there. So it's well covered with the absolute alcohol. Rinse the slide and rinse the forceps as well. There we go. Just to really make sure there's no traces of water, give it a few taps on the side and then straight to the first xylene container. Once it's there, it can stay for as long as needed. There's nothing else that can really happen to it there. Just to demonstrate that again, so tip off the eosin, straight to the 90, putting it in crossways rather than in the slots. Give it a bit of a shake, rinse the forceps, rinse the slide. Then to the next one. So again, rinsing both the forceps and the slide. And then to the final alcohol. So if you get into the habit of saying that to yourself, rinse the forceps, rinse the slide, that's a good technique. So it really should ensure that you're removing all the water. I'm just going to leave those there because I know there's no water on them there. And then I'll grab the last one, use my hand initially, straight to the 90, sideways again. Now into the 90s, so now there's a bit of water coming back on the forceps, but that's okay, we're going to get rid of that as we go through. And it's better to use the forceps, not your fingers, because you can really make sure that you're able to rinse not only the slide, but whatever is holding the slide. If you try and use your fingers, then that's less easy to rinse at each point. There we go. So that's nicely rinsed. Give it a bit of a shake. Do need to be also careful not to bring too much alcohol over to the xylene as well. So just giving it a bit of a tap is quite useful. So there it is. It's all done. They can sit there for a minute or two, and then they can subsequently be transferred to the other xylene for subsequent cover slipping.